Okay. Like now it is, but it wasn't before. Yeah. I don't. I was on paper. That's why. Yeah. But I'm gonna highlight the important stuff. So it says that a baseball player has a lifetime batting average of 0.163, right? It says average, so I know that that's the population mean mu, which is 0.163, right? If in a season this player has 385 at bats, right? So that sounds like an N, right? Is 385, right? What is the probability he gets 45 or more hits, right? So that sounds like X, yep, or more, right? Let me do it like this. They want to know what is the probability of 45 or more. That sounds good, right? 45 or more hits. That's the question, right? Let's translate this into math real quick, right? So this is going to become probability of X. Is it less than or greater than? Which one? Greater than 45. All right. Everybody good with this so far? All right. So now the or more. Yeah. So now, y'all know I don't know how to do this, right? So we got to change the X into a Z distribution, right? So this is going to become probability of Z greater than X minus mu over sigma, right? X minus mu over sigma. But here goes our issue that we have, right? So I know in my 1 second. Technically, this is a P. Hold on. I feel like this is P. This is not mean view. Yeah, I know. My fault. Yeah, yeah. But anyway, right? I need my mean mu. Just real easy. We could find that, right? We know that mu is equal to n times p, right? Just plug in the numbers and get it, 385 times 0.163 and whatever the calculator tells us. I'm gonna do it right here real quick. 385 times 0.163. Let me see what I get. So I got 62.755, right? That's what I got for my mean. I got to find my standard deviation also, right? So we know that our standard deviation is what? Yeah, yeah. So now for my standard deviation, right? I know that that's the square root of n times p times 1 minus p, right? So then now I'm just going to plug it in. Nothing crazy, right? So 385 times 0.163 times, right? And then, but you have to multiply that times 1 minus the 0.163, whatever. Little math, boom, 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 and we're done. I guess. I don't know. I'm not that good at math. Let me see. Square root, right? 385 times 0.163 times, open parentheses, 1 minus 0.163, close parentheses. I got 7.247. No, you're good. You're good. I just type it all in the calculator and I click enter, you know? Yeah. Yeah. For yours? So so for you, if you're doing it on the phone, do the inside first and then do the outside. So no. So 385, right? Times and then 0.163 times open parentheses, and then one minus, hey, one minus, uh, 0.163, close parentheses, and enter. Yeah. And then when you get no, when you get that answer, then you square root it, square root x. Yeah. Yeah. So for me, I just do it all one shot and hit enter. Yeah, that's what I got. Yeah. Yeah. I got you. So that's my mean and my standard deviation that you guys see right here. Right? All right. Remember when we was doing this lesson though, right? That there's a little bit of a correction, right, that I have to make, right? So they're asking for greater than 45, right? So remember, if I'm gonna do greater than 45, I have to go back by zero point 0.5, right? So that means that I'm actually gonna change my x right here. This is a little correction to become x greater than 44.5, right? It is. Yeah. This is a question that I got asked over here, right? So we have to do a little bit of a correction. We have to go to the left a little bit, right? So 44.5. Now that we have all these numbers, just plug them in. Same old, no different. So we got probability of z greater than, this is going to be the 44.5 minus the mean, which is the 62.755, divided by the standard deviation, which is a 7.247478. Y'all know I don't like to round, so that's why I do that, right? Hmm? Yeah. So all I'm doing is the numbers I found, I'm plugging them into the formula right here. That's all. Just yeah, 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 yeah. I just copy from the formula sheet. I'm not making it up, you know? Yeah. And then the next step after that is a little calculator. Nothing crazy. All right. So let me do this real quick. So I got open parentheses 44.5 minus the mean. Give me 1 second. That's what I'm trying to find right now. Yeah. All right. So this is what I got. Which you guys can get on the calculator as well. Just plug it in and you get it. So this becomes probability of z greater than negative 2.51881. Right? Now, if we're going to use a table, we got to break this down into two. You have to have two digits after the decimal. I got negative 2.51881. Awesome. Good. Yeah, good, good. But
Not just that though, right? You want us to write P or PC greater than the answer.
right. But we're not done yet though. So I'm gonna round this off to the nearest 100. Go ahead. Yeah. That's what I'm looking for. Yes. That's the answer for this question. Mm-hmm. Yeah. So I'm gonna round this off to two decimal places. So this is gonna become probability of z greater than negative 2.52. Yeah, you could just leave it. Yeah, yeah. So now you're gonna look this up in the table, but remember I can't look it up in the table because it's greater than, and the table only does less than. So we gotta do the complement, right? So what I'm really gonna do is I'm gonna do 1 minus the probability of z less than negative 2.52. then that's going to be 1 minus 0 point something. Let's look that up. Negative 2.52. I want to look that up. Yeah. Let me let me just verify that we on negative 2.5 and then go over to the 2. Yeah.
Point 0.0059, I got.
All right. So it's at point zero. Oh shoot. 0059. Okay. Everybody else got that too?
Wanna tell me again?
All right. So I'm looking for negative 2.52.
Is it, the negative is table 3.
So let me verify alongside with y'all.
Oh, okay. Yeah, no, that's negative.
So you want to go to the negative table, right?
Yes.
That's it. So look on the board. Over here, I'm gonna do negative 2.5 right here. Right? And then the 100th place is up top here. That's the 2. And then I want to see where do they intersect at. They intersect right here. Negative 2.52 exactly. Right? So what answer do you get when you where they intersect that? That's it.
Yeah.
Right?
So that's our final
Yeah.
answer.
No, we gotta do
No.
1 minus that. That's the
The
final
minus
answer.
that.
Yeah.
Go back down.
Other thing?
Um,
Oh yeah. Hmm. You good?
So now it's 0.0058.
Sorry?
So now it's 0.0058.
59. Yeah.
No, but you said to subtract 1 from that.
Yeah, so 1 minus
1
that.
minus 0.
Yeah. Yeah.
Okay.
So what y'all got? 9941. Good. So this is the answer to the question. All right. So that's question 1. And then question 2. I'm gonna just do one of question 2, and then I feel like you could do the rest after that. Yeah. So look, the first question said for this was 7.6. That one? Yeah. Yeah. So this next question is 8.1. I'm just doing question 1 because the rest of them is kind of similar, right? So question 1 says X bar, right? Plus or minus 1.96 times sigma over the square root of n, right? So what they want from this question is they want to know what is the confidence level, right? So what's confidence level corresponds to 1.96, right? So the way that you do this, right? You go straight to the formula sheet, right? I'm going to show you. You go straight to the formula sheet and then I'm sorry. You're going to go to where the normal distribution table is at the bottom. You have your confidence interval critical values here, right? So what this question did was it gave you the critical value, right? So 1.96, which is right here, right? So right, so that's what they're asking for, 95%. So the answer for question 1 is 95% or 0.95, and that's it. Yeah, and then the rest of the questions are the same. You just find it and match it, and that's it.
Yeah, it's a right.
Yeah. Or you could do the work that we did yesterday where we had the probability in between and you look up the Z critical and all that same thing. Right? Yeah. So this is just 95%, or 95, something like that. And the rest of them, just look them up, same thing. Matter of fact, it's actually multiple choice, so just ABC that joint, and that's it. Yeah. Okay. Yeah. Go ahead. Let's see. It better not be one of the ones I just did. What is that?
Hey, I don't know, then why let me know though?
You
If
see,
you did go look.
that's the exact same question I just
Just
did.
did that?
I
I
just did that.
watching it.
It's this one. You see where it's the 0.994? That's it. Yeah, it's that same question. Yeah.
You know, I wanna make sure, yeah.
Yeah. Yeah. All right. So let's jump into today's lesson then if there's no more questions. All right.
Sorry, Professor.
It's all right. I didn't get to that yet, but I will get to it next week. I got you. Yeah. Yeah. Yeah.
See it up here.
I don't know.
And I went to home stash.
I posted everything for like the rest of the semester. So like that's it. No more new homework. Like that's all it is. That's it. Yeah. 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 Which one?
You know, under the practice final one.
Yeah, that's your practice final.
Yeah.
Yeah. Oh, you didn't want to study for the final? You just wanted to raw dog it? Okay, sure. Yeah. Yeah.
No. No, but we get practice.
You could then just go to tutoring and get it done. Then you know how to do the final and you get 100. Simple. Yeah. Yeah. You ain't even got to print it out. Just bring your laptop and just do it right there. Mm. Whatever the computer say.
Yeah.
Yeah. All right. So interpreting confidence intervals, right? A few comments are in order about the general meaning of the term confidence interval. Since the sample mean is a random variable, the endpoints of the sample mean plus or minus the margin of error are also random variables, right? So past equation states that we have a chance, right? A confidence of obtaining a sample such that the interval, once it is computed, will contain the parameter mu. Population mean, excuse me. After the confidence interval is numerically fixed for a specific sample, it either does or does not contain the population mean mu. So the probability is 1 or 0 that the interval, when it is fixed, will contain the population mean. So a non-trivial probability statement can be made only about variables, not constants. So the equation, probability of the sample mean minus the margin of error less than the population mean less than the sample mean plus the margin of error is equal to the critical value, really states that if we draw many random samples of size n and get lots of confidence intervals, then the proportion of all the intervals that will turn out to contain the mean mu is the confidence level, right? Or whatever they give you, right? So for example, in our previous figure, right, the horizontal lines represent the 90% confidence interval for various samples of the same size from an X distribution. Some of these intervals contain the population mean, others do not. Since the intervals are 90%, whatever, confidence intervals, about 90% of all such intervals should contain the mean mu for each sample. The interval goes from the sample mean to the minus the margin of error to the sample mean plus the margin of error, right? So let me give y'all a nice little picture just to, yeah, yeah.
Okay, this, I don't even know what you're trying to say.
So I'm trying to explain like what is a confidence interval? right? So the idea is, right, you're taking a sample, right, from a population, and then you're getting statistics on that sample, like the sample mean, right? But I'm not interested in the sample mean. I want to know what is the population mean, right? So the whole point of this is to find an estimate of what the population parameter, in this case, the mean, could be, right? That's what I'm trying to do here. Mhm.
It's trying to find the parameter.
Right. It's trying to find a parameter. So population mean is an example of a parameter. So look, just to get a little bit more advanced with you for a second, right? This topic of estimation, right? We're only focusing right now, like for the whole class, on the population mean, right? But you can actually find a confidence interval for all the population parameters. You can find it for sigma. You can find it for sigma squared. You can find it for rho, et cetera, et cetera, et cetera, et cetera, right? But for our class, we're just focusing on the mean, right? Just keeping it simple. We just want the idea of what a confidence interval is,
So.
right? Mhm.
Confidence B, which is 30%,
Mhm.
and that obviously that equals the 1.645. How am I supposed to plug that into this equation?
You use the error formula. You plug it into that, and then that gives you the margin of error. Mhm. So the one that we just did was margin error E is equal to Z critical times the standard deviation sigma over the square root of N. Yeah, Z critical times the standard deviation sigma divided by, yeah, divided by the square root of N.
Should I
Yeah.
parentheses sigma over square root of n? Should I put that into parentheses?
If you want to, up to you.
Just
Yeah, if you want to, yeah.
So just to clarify. Like that,
Yeah.
margin E equals.
Yeah.
I'm sorry,
That's it.
equals Z C
Mm-hmm.
sigma
Over
over
the square
square
root.
root of n.
Mhm.
And when
That's
you
it.
say square root of n, you
Mhm.
mean, you don't mean 5 times 5, you mean 2.5, correct?
Whatever N is.
No, I
Whatever.
mean, like, let's say n
Yeah.
is 5.
You
So
just
you don't
plug,
mean
you
5
just
times
plug
5,
in
you
five.
just mean 2.5,
No, square root of 5.
which is 2.5.
Oh, it is? I don't know.
2.5
Yeah.
times 2.5 is not 5. That's it.
If you say so. I don't know.
But you get the point, right?
Yeah, yeah,
It's
yeah.
not 5 times
Right.
5 is what times.
Like say
5.
say N was 36.
It's
It would
6.
be 6, like that. Yeah. All right. Yeah. So once we have a specific confidence interval for the population mean, such as 3 less than the population mean less than 5, all we can say is that we are confident or percent confident that we have one of the intervals that actually contain the population mean mu. Another appropriate statement is that at the C confidence level, right, our interval is one that contains the population mean mu, right? That one is actually my favorite. So let me show y'all a little graph real quick just to put this into perspective. All right. This thing is like mad huge. Hold on one second.
Go back to what you said. You're saying, okay, cool, you got the sample,
It's better.
but you want the whole population?
That's what I'm interested in, right?
So
Like again, right? Like
you don't want
I
the
could I
sample,
could
you want-
ask, right? Like I could ask you guys, right? What y'all think about Mondami, right? But but I don't really care about what y'all think. I care about what New York City thinks, you know? But what all I could do for whatever reason, like maybe I don't have enough time, enough resources, enough money, whatever, to ask everybody what they think, right? I have to take a sample and then use that to estimate what I think the whole city thinks, you know? So like that's the whole thing. Like I'm not, even though I'm asking my sample, you guys, what you think, I'm not really interested in what you guys in particular think. I want to know what the whole city thinks, you know?
Okay, it's
So mhm.
also.
No, no, no. I'm just using this to explain something, right? So at the 90% confidence interval, right, for samples of the same size, right? Each one of these blue lines, right, that represents a sample that was taken, right? So when I say that I'm 90% confident, right, that the sample that I have contains a population mean mu, right? Let's say that mu is this black line, right? As you can see, some samples might have mu in the dead center. Some samples have mu on one end, some sample have mu on the other end. Some samples didn't even capture mu at all, right? All of that is possible, right? So, yes, I am finding a confidence interval, but just know that there's a chance that the interval itself doesn't have the mean, right? Yeah. Yeah. So this is just like a visual representation of what I just said, basically.
There's some, like, I understand everything you say, except this X bar take away E to X bar divided by E.
So the margin of error, that's how I get the range, right? I need that E to give me the range from this number to this number. I believe in between there is the population mean, you know? Mhm. X bar is the mean. No, no, X bar is the sample mean, excuse me. Right.
Does that mean from the, like that side?
X minus. So X minus is the left side.
Yeah.
X plus is the right side. Yeah, 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 yeah.
When you put it like that, it's a little easier.
Mhm. All right. So what does a confidence interval tell us, right? So a confidence interval gives us a range of values for a parameter, period. That's what it tells you, right? A confidence interval for a parameter is based on a corresponding sample statistic from a random sample of a specified size n, right? So a confidence interval depends on a confidence level. Some common values for a confidence level might be like 0.90, 0.95, right? Which is there, 0.99, right? But as what we learned yesterday, we could find a confidence level for any probability, right? We could find 0.77 if we wanted to, right? All that means that that's the area in between, and we're finding Z critical on the positive, and that's it, right? If we take all possible samples of size n from a population and compute a confidence interval for each sample, then the confidence level of all such confidence intervals will actually contain the population parameter in question. Similarly, one minus the confidence level of a confidence interval will not contain the parameter, right? That's understandable, right? So if my confidence level is 90% and I do 1 minus 90%, I'm going to get 10%, right? So 10% of the samples will not contain the population mean, right? That's just the what you call it, the
So,
complement. That's the word I'm looking for. Mhm. Mhm.
so we could put a problem where we plug everything in, but then we have to do one minus that. So,
Because it's greater than, and our table only gives us less than.
so when it's greater than, you have to take away your answer, and when it's less than, you don't do one.
Right, you just copy it, and that's it. Mhm.
So you see, that's important.
Mhm. All right, so when we use samples to estimate the mean of a population, we generate. So when it's greater than, you do one minus the probability from the table to get your answer. When it's less than, you just copy whatever's on the table. So
What do you mean by copy what's on the table? So if this 90% is 1.645, and that's it?
no, like if I had probability of Z less than 1.00, You just copy what's on the table, the answer there. But if it was like probability of Z greater than 2.00, you have to do 1 minus whatever the table gives you. Yeah. Yeah.
Yes.
Got you. I got you.
Right.
So when we use samples to estimate the mean of a population, we generate a small error. However, samples are useful even when it is possible to survey the entire population because the use of a sample may yield savings of time or effort in collecting data. All right. Good stuff. Right after we do size. And this is like really interesting and important to know too, right? Say you're running an experiment, right? And you want to be confident to a certain level, right? Let's say that we make up a new drug, right? Let's say a drug that makes you younger whenever you take it, like a pill or something, right? And we want to be 99% confident that the drug works, right? So how big of a sample do we need to take to be able to say that like this drug definitely works? Mhm.
0.58. So then we will.
But that's not the sample size. Mhm. No, that's not the sample size. That's just the Z critical value. So what we're gonna talk about right now is how to find that sample size. All right. So look at this, right? In the design stages of statistical research projects, it is a good idea to decide in advance on a confidence level you wish to use and to select the maximum margin of error. You want for your project, right? You want for your project. How you choose to make these decisions depends on the requirements of the project and the practical nature of the problem. Whatever specifications you make, the next step is to determine the sample size. So solving the formula that gives the maximum margin of error E for N enables us to determine the minimum sample size needed to run your experiment. Mhm.
Over.
Yeah, it is that. Yeah. I remember you guys don't know how to solve literal equations, so yes. Yeah. 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 Yeah.
The way he's clowning us right now.
No, for real, for real. That was a topic we went over, how to solve literal equations. Yeah, it is on the final. Yeah. But but the formula sheet low key did it for you. So let's talk about that. All right. Yeah. You're not gonna put it up on your wall? In case. So look, here's a procedure, right? Before we go into an example. So this is how to find a sample size n for estimating the population mean mu when sigma is known, right? So here's the requirements. I got you. I got you. I got you. So here's what you got to know, right? You got to have the distribution of the sample means X bar. It has to be approximately normal, right? Here's your formula, right? It might look new, but it's the same E formula that y'all had from before. They just solve for N, right? And I know y'all know how to do that because y'all can do, yeah, but you know how to do that. That's from the literal equations, right? How do you undo a square root? You square it on both sides, right? Same thing, right? So anyway, here's the formula. It's on your formula sheet. So if you don't want to write it down, it's there already, right? So this is all in chapter 8, right? So N.
That's the distribution of sample means.
Mhm.
X bar is approximately normal.
The question that they ask has to say that the X distribution is approximately normal. If it doesn't, then you can't use this. That's all that means. Right. It has to say that in the wording of the question. If it doesn't, then you can't use it, basically. Right. Mhm. So the formula, huh? when sigma is known, right? So the formula for this is n is equal to z critical times the standard deviation sigma divided by your margin of error squared, right? And then that's going to be the minimum sample size needed to be at a certain level confident that your interval is going to contain the population mean. All right.
For to give you the minimum what?
The minimum amount of samples you need to be confident that your sample contains the population mean.
Minimum set.
Right. Long story short, right? I'm trying to figure out how many people, how many y'all I gotta ask, right? To know. Wait, let me word this a different way. I want to know how New York City feels about Mandami, right? So to figure that out, I'm trying to figure out how many people I gotta ask so that I could get an idea of how New York City feels about Mandami. Right? How many of y'all do I have to ask to get that that idea? That's what this is. All
You
right.
see where E specified maximum margin of error?
Right.
Equals population standard deviation, what's the?
So just know that those are numbers that would be given to you in the question. All right. And then Z critical is our critical value from the normal distribution for the desired confidence level C. Commonly used values of Z critical can be found in the table of the appendix, which you all see and have, right? If n is not a whole number, increase n to the next higher whole number. Note that n, right, the sample size, is the minimum sample size for a specified confidence level and the maximal error of estimate E, right? Blah, blah, blah. So I plug in these numbers and I get an n. My n comes out to be 500.45, right? I don't care what decimals there. Bump it up to the next number, right? No, to like 501, right? All right. Whatever answer you get for n, round it up to the next whole number.
So this 40.
Yeah. 46. Yeah. 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 Mm-hmm.
So critical is round up, I'm sorry,
For the n formula, right? Just round up to the next whole number. That's what I'm saying. All right.
Now, what do you
Mhm.
mean when you say note that n is the minimum sample for a specified confidence level and maximal error of estimate? Is it repeating itself? Because I'm getting confused.
It is, yeah. So basically, like this n that we're finding, the sample size that we're finding is the smallest sample that I need to contain the population mean, right? Mhm.
Size
Yeah,
is the maximal error.
right. Yeah.
Jesus Christ, you could just said that.
Right. So in a sense, it's like you're choosing how much error you want to be in your experiment. And from that knowledge, you're trying to figure out how big of a sample do you need, you know? So yeah, it's all right. Yeah. So if you have a preliminary study involving a sample size of 30 or larger, then this is a comment, then for most practical purposes, it is safe to approximate the standard deviation sigma with the sample standard deviation S, right, in the formula for the sample size. All right. So basically, like if we have n that's greater than or equal to 30, we could just treat that like sigma. That's what they're trying to say. 30. No, if I have 30 or more, I could treat the sample standard deviation as sigma.
So
Mm.
that's
Yeah.
your chosen sigma.
No. If I gave you a sample standard deviation and I gave you a sample along with it that was 30 or bigger, you could treat that sample standard deviation as sigma.
All right, hold on.
Yeah.
So says here, we'll have a preliminary study involving a sample size of 30. So 30 is sigma.
30 or more, but yeah.
Or more. Now,
Yeah.
if I have another
30 is
question
not
for-
sigma. 30 is your sample size, how many samples you have. Yeah. No, sigma is the population standard deviation. Yeah. Yeah. Say it again? No, E is the margin of error. That's how much error you're allowing in your experiment.
So,
Hey.
said,
Which one? You see? That's capital sigma. That means the sum of. That's when you add up all the numbers in it. Yeah.
the sample size of 10 or larger, then I'm gonna treat 10 as one sigma, right?
No, it's 10. 10 is not 30. That's less than 30. It has to be 30 or more. If yeah. If the sample is 30 or more, then you can treat the sample standard deviation as the population standard deviation. Yeah. I got you.
Sam
Yeah. Mhm.
deviation of
Mhm.
30 or more
Right.
can be treated as sigma, which is the population standard deviation.
Right.
You see, Professor, it's very, believe it or not, guys, if y'all not writing those stupid little fucking details,
Yeah.
that'll make you fail the test.
Not necessarily. What happened? It's all on your formula sheet, it's in chapter 8. Yeah, yeah, look in chapter 8. It's right there. Yeah.
It says sample size for estimated and tell them
Mm-hmm.
the
It's all there.
yeah, it's like.
I'm gonna believe you did together.
So let's do an example real quick. All right. This is real simple. A wildlife study is designed to find the mean weight of salmon caught by an Alaskan fishing company. A preliminary study of a random sample of 50 salmon, right? So we know that my N is 50.
Yeah, you can treat that as.
Salmon, not sigma, right? Yes, we can treat, right, because it's more, right? Yeah. Mhm. Yeah. So preliminary study of a random sample of 50 salmon showed that the sample standard deviation is equal to 2.15 pounds, right? How large of a sample should be taken to be 99% confident, right? 99% confident that the sample mean X bar is within 0.20 pounds of the true mean, right? That's my margin of error. 0.20 pounds of the true mean, right? So I'm looking for a sample size, right? Go ahead. All right. So this is not the N that I'm looking for that was given in the story, right? This N is how they found this sample 2.15 pounds, right? But I want to be 99% confident that my next couple of samples I take will contain the population mean, right? So how big does that sample need to be? That's what I'm trying to figure out. Mm-hmm.
Squared over E.
Hmm?
So we gotta plug everything in.
That's it. Just plug it in, right?
Wait, what?
Z critical times sigma over the margin of error. Yeah, nothing crazy here. Just plug it in, squared, of course, and it's going to give you an answer, right? But we got to figure out what is Z critical, and how do I figure out Z critical? Right. So
And go down to the 8.
go to the 99%, and what's the Z critical value there? 2.58. Okay. That's it. Yeah, the table, right? Yeah, let's verify it together real quick. So no, it's this one, this little table right here, right, where it says confidence intervals. So I'm going down to 99, and then the critical value is 2.58, right? Right, that's it. So then now, going back to my formula up here, That's what I'm gonna plug in. So this is, yeah, 2.58. I don't know why I put that there. Times the standard deviation, which is 2.15,
Oh, it's nice. I thought it was.
Mhm.
Sixty.
divided by the margin of error, and then you're just gonna square it. Little calculator, bop, bop, bop. Let's see what we get. No, the sample standard deviation. I needed to see, yeah, I needed to see that 50 though, so that I understood that I could treat this sample standard deviation as sigma. Right. Right. Yeah. Huh? This sample size of 50 right here, this for the 50 salmon. It's because I took 50 salmon that I could treat the sample standard deviation as sigma, right? Because of the end. Anyway, little calculator, and then that's it. That probably is. Let me do it real quick. Yeah.
I don't wanna say it out loud. Let's see what I got.
See.
And we probably know, yeah. So that's what I mean.
No, I didn't swear it. I'm wrong, Professor.
Let me see.
I didn't swear it.
I didn't put my equal sign. So we in the same boat. All right, so
Yeah.
close enough. All right. I got 769.2302. Right? That's all right. Just plug it all in and it'll work. All right. Yeah.
On the rest of
Yeah. Yeah. On that, so open parentheses. Then you want to do 2.58
that was one.
times 2.15 divide 0.2, close parentheses, and then square the answer.
The square, the X2, right?
X2, yeah.
Okay, I did the other square.
Yeah.
So you see, I did
That's it.
the line with the 2 and the X. I didn't do the X2. That's what I did.
So even though I have all these decimals or whatever, I'm not interested in that. Go to the next number. 770. That's my final answer.
But if-
So no, I want 770. Right? Because what is 0.32302 of a salmon? What does that even mean?
Okay,
Yeah.
so is the number right? Professor wants it to be 770.
Right. A whole number.
Oh,
Right. I want to know how many salmon I gotta capture to figure this out. Right. Mhm. And bears ain't eating tonight. Mhm.
but if it was 76, it should be 77, correct? But because it's
Right.
three numbers, you
Right.
made it 77.
Yeah.
I don't know how the fuck I'm following you, but I'm fucking following you.
That's good. That's good. So now we can run our own experiments. All right, no problem.
Oh, I'm gonna put carrot cake with salmon.
Yo, that sounds fire. They, I mean, they actually got all of that in Roscoe Brown on the first floor. It's a winter social. It's free. It's winter social. It's free. They just giving it out. No, it's free. They're giving it out. They're giving it out. It's free. Yeah. Nah, the winter social is free. You just go. Yeah.
Yeah, we gotta go to the
Yeah.
beach. Okay.
All right. As long as you guys get to the pantry before 6:15, y'all good.
Yeah.
Yeah. Tonight, 6:15 tonight. Yeah. Yeah. Yeah.
What is it? Yeah. I need to know where to put my stuff. That's why I'm gonna stop.
That's because it was Thanksgiving. That's why it was packed. Yeah.
But you're not.
Yeah,
I got 21.
yeah, that's true.
Way.
They did say that every day. Yeah, well, you more to come in the morning, but yeah. But they're not making that.
I would never want to have to be. I'm never gonna get anything, but they don't have garbage.
They took my garbage can. They mad at me. Yeah. I didn't even know. It's okay. It's all good. So I'll shoot y'all a video with an update.
Yeah, sorry.
Mhm.
Okay.